Hi, I'm Noam Honig. I'm a full-stack developer and I love TypeScript. What I don't like is application logic spread between front-end code and back-end code when it actually belongs in one place. I'm also a lazy developer, so I like my code short and simple. And I really don't like maintaining API routes with boilerplate code. That's why I created Remult, a CRUD framework for full-stack TypeScript that makes life easier. Remult uses TypeScript entities shared between front-end and back-end code. The entities serve as a single source of truth for database queries, REST API routes, access control, validation rules, and type-safe data fetching for the front-end. Let me show you how in just a few minutes I turn a front-end only React to-do app into a full-stack app with a Postgres database including server-side, paging, sorting, and filtering, full CRUD operations, validations, server-side logic, authentication, and authorization. Let's go!
Here we have a React to-do app that uses Vite. We can see the task is defined here. We have the state for the task array, a state for the new task title, and an add task function that enables us to add sleep, eat, work. Using the setAllCompleted function, we can set them all as completed or uncompleted. We can tick individual tasks by using the setCompleted method, and we can delete tasks using the delete method. Let's turn this app into a full stack to-do app. To do that, we first need to add a backend folder and an index.ts with a standard express app. Next, we'll start the Vite dev server and run the npm dev script, which will start the Vite dev server and the express server we've just written. Now, let's add Remult express middleware and use it here. Now that we've completed the setup of the backend, the first thing I want to do is share the task type between the frontend and the backend. To do that, I'll add a shared folder and drag the task to it. Using Remult, a TypeScript entity class becomes a single source of truth for everything our application needs around that entity. The entity decorator tells Remult that this class will be used as a model for both front-end and back-end code, so Remult should create CRUD API endpoints and a database table for this entity. Here, I'm telling Remult to allow all CRUD operations. Later, I'll restrict that. We also have decorators for their fields to define their data type and behavior. Now, let's register it with our API. We can see that as soon as we save this file, the Node.js server restarts and the new API test route is added. Let's test it. Make a standard API call to our backend. We see that we get an empty array, and let's post a few tasks. Title, work, eat, sleep, which I have completed. And if we use the get method, we get this item set. Remult provides a JSON database to be used in development, as you can see here. Of course, you can use Remult with a wide selection of databases, including Postgres, MongoDB, MySQL, and many more. Let's adjust the code to use Postgres database. I'll go to index.ts, import Remult Postgres, and set the data provider to create Postgres connection with our connection string. As soon as I do that, we get a new Postgres table created. If we run the get method, we see that we don't have any rows because it's a new table. Let's add a few tasks so we can work with them later. Setup, we've completed. Database, we've completed. And paging, sorting, and filtering, we will work on now. On the front end, I've used Vite proxy feature to forward all requests to API to our Express backend. Let's use Remult to get the data from the server. In our React app, we say const task repo of task. We ask Remult to provide us with a repository object. We will use this task repo object to interact with the backend. Let's use its find method to get the task from the backend. We got the task from the backend, and we can see the task API calls here. Let's have a closer look about what we can do with this find method. I can limit the results. I can ask for the next page. You can see that it's all just basic REST API calls. I can sort the data using completed ascending or descending, and I can filter the data showing only completed tasks, uncompleted tasks, or all tasks. These definitions go through the REST API request and into the database query on the backend. Remember, all I had to do was write a simple TypeScript class and register it with Remult, and I get a type-safe API client with full autocomplete and an API endpoint that fetches data from the database table that was also created for me by Remult. Cool. Now let's adjust the code of the add task method to use task repo insert. And let's add the task we want to complete. See that it's a simple post call to the backend. Backend Logic, Authentication, Authorization. So now we have the list of the tasks we want to complete in this presentation. Let's adjust the setCompleted method to save these changes. So let's go to setCompleted and say here, await task repo save. Now, as I tick the tasks, we can see put requests being sent to the backend. Now let's fix the delete task method to delete. And let's add a task and delete it. And we can see the delete call here. And last, let's add a save task method that will await task repo save of task, which will actually save our tasks, and call it on the onBlur. So now if we edit something and leave it, a put call is made to the backend to save it. And let's add try, catch, and an alert. Did you notice I didn't write any backend code to get the rest of these CRUD operations to work? That's because with Remult writing simple full-stack CRUD is, well, simple. Now let's see how with Remult I can add data validation to the task entity and have it affect both the front end and the backend. Let's send an option object to the title with validate, validator required. As soon as I've done that, if I try to save a task, I will get an error. If we clear the network tab and try it again, you can see that there's no request being sent to the backend because the validation check is done by the JavaScript running in the browser. Now let's try and bypass that by sending a post request with an empty title. Doesn't work, and I get the same validation error from the API. Of course, you don't have to use predefined validators. You can use any arrow function to validate your data. For example, I can say here, task, if task title length is less than 3, throw arrow too short. As soon as I do that, the front-end validation will indicate the too short arrow, and the backend will do the same. Let's have a look at our setAll completed method here. Let's adjust it to save the tasks. We'll get the tasks from the backend and save them one by one. And reload the data. So now when we kill setAll completed, it works. It works, but it's not efficient because it's sending multiple requests to update these tasks. Let's refactor this code to run it on the backend instead. Let's create a new file in the shared folder and call it tasks controller ts, export class, and copy the setAllCompleted method from the frontend code to our new class. Let's make it static and decorate it with the backend method decorator. The backend method decorator tells Remult that if I call this method from frontend code, don't run this code, but instead send an API request to run it on the backend. All that's left to do is to define a test repo, just like we did before, and that's it. We can use the same CRUD syntax both in frontend code to interact with the API and in backend code to interact directly with the database. Let's register the task controller here. And in the app TSX, instead of calling this for loop, I can say await task controller setAllCompleted completed. So now when I click on setAllCompleted, we can see a single call to the backend. One more important thing we get from this is type safety for our API call. So if I try to send a string instead of a boolean, TypeScript will tell me that I've made a mistake. The last thing I want to show you is how I can use Remult to control access to the REST API using simple declarative code. Let's say that I want to restrict the API so that only authenticated users can create, read, and update tasks. All I have to do is say allow API CRUD, allow authenticated. And as soon as I save and refresh, we can see that the request fails because I'm not authenticated. Let's add a sign-in feature so we can make this app usable again. You can choose any way you like to implement an authentication flow. All you have to do is tell Remult how to extract the current user from any incoming request. For this demo, I'm going to use Express Cookie middleware, and since this is external concern to Remult, I'll just use a snippet over here to add cookie session authentication. We have a list of valid users, we have a simple sign in and sign out method. Real-life authentication flows are much more complex than this, but for a demo, this will do. Now let's tell Remult how it can extract the current user from the request. We'll add a getUser method and say request session user, which will extract the user that was set here in the sign-in. Now let's go back to the front end and add the user sign-in. To do that, I'll add to the main TSX an auth component I've prepared in advance. Let's review this auth component. It has a sign-in username, current user, sign-in and sign-out functions that call the API. Let's try it out. I'll sign in as Steve. And now you can see the to-dos again. And I can also update them. Let's go back to the task entity and add another restriction. Only users who have the admin are allowed to delete. As soon as I do that, Steve can add, but Steve cannot delete. You can see that we get an error. Let's make Jane an admin. Now I'll sign out and sign back again with Jane. And we can see that Jane can delete.
Well, there you have it. Full CRUD operations across the stack with no boilerplate, end-to-end type safety, sharing code between front-end and back-end, and a single source of truth, our TypeScript entity. These are the core features of Remult, and if you want to find out more, go to remult.dev. Thanks for watching!